Okay, this is going to be 1.3 notes. So we're doing applications of inequalities. So we want to make sure that we realize that these are going to be inequalities. We're going to have that in our answer. When you get done with the inequality, you must make sure that you actually answer the question, because it always doesn't get to be just a single number. So we're going to make sure that we probably write as a statement. So let's read the first one. For a company that manufactures aquarium heaters, the combined cost for labor and materials is $21 per heater. Fixed costs incurred in a given period, regardless of output, are $70,000. If the selling price of a heater is $35, how many must be sold for the company to earn a profit? Okay, so that's why I wrote profit at the top there. So don't forget that what we're trying to do, remember the profit is actually the total revenue minus total cost. Okay, so when we have that, we want to make sure that we give that information with our little formula there. Okay, so what we have is that we have cost of $21 per heater. Okay, aquarium, the combined cost for labor and materials $20 per heater. Then we have fixed costs occurred in a given period, regardless output is $70,000, and then we have a selling price. Selling price is $35. So we got to remember which is which for us. So first, remember, we're always going to define a variable. So I am going to and I like to use Q for quantity, so Q, let's just have it because they do as well, be the number of heaters sold. Okay. Now, they want to earn a profit, so let's put number 1 there. So the profit, remember, if I want to earn a profit, that means my profit has to be greater than 0. So for this right here, we want profit to be greater than 0 in order to earn a profit. So let's set up our equation. So I'm going to go total revenue. So total revenue, remember, is what the selling price is per unit. And so we see that it is $35 per unit. So I'm going to do total, I'm just put it right here, total revenue is $35 per unit. So it's 35 times Q, $35. And then minus the total cost. Okay, remember, total cost is the fixed cost plus the variable cost, okay? So be careful, make sure that you put yourself in a parentheses here so that you distribute correctly. Okay, so we're just going to, so the fixed cost for us, no matter what, is $70,000. Okay, but the heater, to make a heater, the labor and material is $21 per heater. So that's going to be my variable cost, which is $21 times Q. Okay, and that's profit. Profit has to be greater than 0. So my inequality over here has to be greater than 0. Okay. We solve. Okay, so when I solve, I wind up with Q being greater than 5,000. So what does that mean for us? So this is my second thing in here that I'd like for you to do. So this is the second thing we do, figure out the formula, get a number, and then the last thing we'll just kind of make a statement, okay? So we know that heaters can't be negative. So we know that and the quantity has to be greater than 5,000. So I'm going to state that in order for the company to earn a profit, okay, they must sell at least 5,001 heaters. That's the least amount, okay? Could be greater than that, but the least amount is 5,001. So that's what I was talking about with the inequalities. You're going to have to write out a statement to make sure that you know, once you get this quantity answer or so forth, what does that mean? Okay, if they do it 5,000, they're not going to make a profit, but if they sell 5,001, they will. Number 2, right? We have a builder must decide whether to rent or buy an excavating machine. If he were to rent the machine, the rental fee would be $3,000 per month on a yearly basis, and the daily cost, gas, oil, and driver, would be $180 for each day the machine is used. If he were to buy, his fixed annual cost would be $20,000, and daily operating and maintenance costs would be $230 for each day the machine is used. What is the least number of days each year that the builder would have to use the machine to justify leasing it rather than buying it? So what we have here is we have just pretty much renting versus, let me put it up here. It's renting versus rent versus buy. Okay, so we want to know what is the least number of days each year the builder would have to use the machine to justify leasing it rather than buying it. So what I'm going to do, if you think about it, we want to think about, there's two things happening: the cost to buy it and the cost to lease. So we have an inequality. We want to know, if I have the cost of renting and I want to know the least number of days, I want to know that has to be less than the cost to buy for our days, okay? So what we want to do is figure out how to set this and put our equations in there. Okay, so the first thing I want to do, what is the least number of days each year that the builder would have to use the machine? So the first thing I want to look at is define my variable. So I want to let D equal number of days each year the machine is used. And I'm doing each year because it specifically said in the problem on a yearly basis. So I'll be very specific about how I state my variable. Okay. All right, so let's kind of use like our highlighter and things to go through here. So I'm going to use different ones. So I'm going to talk about the renting part first, so I'll just use green. If we were to rent the machine, the rental fee would be $30,000 per month on a yearly basis, and the daily oil and gas would be $180 for each day the machine is used. So I'm going to use a different color for buying. If you're to buy it, his fixed cost, annual cost would be $20,000, and this kind of annual cost, it's already told us it's $20,000, and daily operating cost would be $230 for each day. Okay, so now we just have to set up our equation. So for the cost to rent, right? So the first thing we want to look at, we have two things happening. We have a rental fee that's happening $3,000 per month on a year for the year, and then we have just a daily cost of for the machine. So let's do the first one. So the first one we have $3,000. All right, $3,000, okay, per month though on a yearly basis. So that means he's doing $3,000 for the first month all the way for one whole year. So we have to multiply by the 12. And then the other part is we would be $180 for each day the machine is used. Well, we said D was our variable for that, so it'd be 180 times D. Okay, and my inequality is less than. Now let's look at how much it would cost to buy. Okay, so in this one, I have an annual fixed cost of $20,000. So I don't have to do anything else to that. And then, but for each day, it's going to cost me $230. Okay, so now let's solve for D. Okay, so solving this way, I got 320 is less than D. Okay, so remember this is equivalent, so I'm going to write the D first. So D has to be greater than 320. I like writing that out because it makes better sense to me when I read it. So this is just telling me, so this is the first thing we did, the second thing. So now our third thing is our statement. Okay, so the builder must use the machine at least 321 days to justify renting. So anything less than 320 less, then it's a better investment, or whatever how you want to say that, to actually buy it. Okay, and you can always check this, and figure out what makes sense. Like if I did 319 days, what would happen? And actually, I did work that out. And when I did 319 days, and I substituted in, I got that the rent was going to cost him $93,420, where to buy would cost him $93,370. $93,370. And so there, it's still, this is more than this, so why rent? Go ahead and buy. Okay, number 3. After consulting with the comptroller, the president of the Ace Sports Equipment Company decides to take out a short-term loan to build up inventory. The company has current assets of $350,000 and current liabilities of $80,000. How much can the company borrow if the current ratio is to be no less than 2.5? Note, the funds received are considered as current assets and the loan as a current liability. So I want to make sure at this point we kind of look at some definitions. So remember what, if you're not sure, so current assets are cash, merchandise and inventory, as well as accounts payable, which is just money that's coming in that you are making money off of it. People have to pay you, they owe you something. Okay, so that is going to be current assets. All right, current liabilities, for sake of this, what we're doing here, so current liabilities are short-term loans, and taxes payable. This is you paying out. Short-term loan you're paying back. That's a liability. Okay. Now, if it talks about a current ratio, okay, a current ratio is just of a business is the current assets to its current liabilities. So I'll just write it as so if it's a ratio, that is a fraction. And I'll just put it down here. So current ratio is current assets divided by your current liability. Okay, So let's look at how we would write an equation. So the first thing we want to look at, we have, just make sure I'm going to do it in different colors. So my assets are $3,500. My liability is $80,000. The current ratio, though, has to be no less than 2.5. So that kind of helps us why we have an inequality happening here. Okay, so first let's define our variable. Okay, so we're going to let x equal, now we're going to use x, amount of money they can borrow, because we want to know how much money can be borrowed. Let x equal the amount of money that can be borrowed. Okay, so now really right here we have our equation, so let's write down our information that we have to write this out. So current assets are $350,000. But look, remember the note, because the note says, note, the funds received are considered an asset and a current liability. It's actually both for us, okay? So that's going to be the X. That's the amount you can borrow. So now I'm going to do the here current asset. So it's going to be $3,500. So I don't know why I keep saying $3,500. $350,000. Plus, though, the amount we can borrow because of this part right here. Okay. Divided by the liabilities. Again, we have $80,000 in liabilities, but the loan also is liabilities. We're going to add X. Now, we're writing inequalities, so the current ratio is to be no less than 2.5. So if it's no less than 2.5, that means it has to be greater than or equal to 2.5. Okay, so now let's solve. So if we have a fraction, again, just if you look at this, you'll be telling yourself, wait, this is not really a linear inequality because we have that x on the denominator. But all of the inequality that must be solved is not linear. It is equivalent to a linear inequality, okay? So we have this, we're going to cross multiply. Remember, we have fractions, so we're going to cross multiply. And so, all right. 350,000 plus x is greater than or equal to 2.5 times . Okay, after solving and getting down to x, again, I like to write it where x is less than or equal to $100,000. Okay, so what is this asking us? Okay, so what's this telling us? So let's write our statement. Let's call it number 3. Okay, so the company may borrow, because that's what we're looking for, as much as $100,000 to maintain a current ratio. I'm just going to write this out. I don't think I did this in class, but to maintain a current ratio greater than or equal to 2.5. Looks like a right, last one from this section. A publishing company finds that the cost of publishing each copy of a certain magazine is $1.50. The revenue from dealers is $1.40 per copy. The advertising revenue is 10% of the revenue received from dealers for all copies sold beyond 10,000. What is the least number of copies that must be sold as to have a profit for the company? So that right there, again, that profit kind of tells us something. So here, we want this to be greater than 0. Okay, profit's greater than 0. Now, what we want to do is set up our thing. What are we doing here? Again, this is profit. Profit is equal to total revenue minus total cost. Okay, so we have a profit. So let's go back and look up here what we need, okay? So a publishing company finds that the cost of publishing each of the certain magazines is $1.50. So I'm just going to use a different color for each thing. So if cost is $1.50, so we're just going to highlight this in green. This is cost. This goes with total cost. Total cost of each copy is $1.50. The revenue of dealers is $1.40 per copy. So this is revenue, so I'm doing revenue, okay? The advertising revenue is, so here's some more about revenue. 10% of the revenue received from dealers for all copies sold beyond 10,000. And the thing we want to know is, what is the least number of copies that must be sold to have a profit for the company? So let's define our variable. Okay, we're going to let X equal, I'm sorry, I like to do Q. Let Q equal the number of copies sold. Very straightforward. Okay, so now let's just set up our equations. So let's talk about what we're doing. So the profit, we know has to be greater than 0, so I'm going to move that to the other side, but I'm going to do total revenue first. Total revenue has two things happening, okay? For total revenue, we have the selling of the magazines, plus the advertising. We're getting revenue off of that. So I have two things happening here, so I want to make sure that I set that up, okay? So the selling of the magazines, I'm going to put that over here, is $1.40 per copy. And that's going to be Q, okay? Or you can do 1.4. Now, the advertising is a little different. Okay, so first of all, they get 10% of the revenue received from dealers for all copies. So whatever you do beyond 10,000, you're going to get 10% of that, okay? So that's the 10%. So I'm going to do 0.10. I think that's too many zeros. I'm just going to put .10. Okay. I'm going to multiply that. So here, that is your percentage. 10%. Okay. Now, it's 10% of the selling of everything. Okay, so no matter what you sell it, it costs you $1.40. Okay, but what are you doing? So remember, it's always got to be some quantity here. This has to be $1.40. It's the selling, the revenue received from dealers for all copies sold beyond 10,000. So look at it this way. They sell 10,000 and it's beyond, so they have to, so if they sell 10,000, that's breaking even, so they don't get any of this advertising money. But if they sell 10,001, then they actually get 10% of of that one copy they sold. If they sold 10,002, they get 2,000, and so on and so on. So what we want to know is, like, you have to sell 10,000 copies before you can actually get any of this revenue, okay? Now, the thing is, it has to work for us for any of this, for this to work, period. So I'm going to say Q minus 10,000. Okay? So there's your selling price. Here, this is your cost per the selling price. And this part is your beyond 10,000 copies. You have to sell 10,000 copies before this works. Okay, so that's just revenue. Okay, I'm just kind of giving you an idea about it, so I'll probably clean it up a little bit. Minus the total cost. The total cost is $1.50, 1.5 per the quantity. And we want to make a profit. So all of this has to be greater than 0. Okay? So again, the selling the magazines, that's straightforward. But the advertising, in order for you to get any money, you have to sell above 10,000. And when you do that, you get 10% of that price. So we're going to clean this up. Okay, so there's the math. So we come up with Q is greater than 35,000. Okay. So, but we have to sell greater in order to receive a profit. So what is our statement? So the total number of copies sold must be at least 35,001 copies to make a profit. Okay. So they can sell 35,002 and still make a profit, but they sell at least that amount.